This is part 6 of section 4.2. We're going to be using a calculator to find the approximate value of each expression. And we were asked to round our answers to two decimal places. Okay, so we're going to plug these into calculators. We're not going to be able to get exact answers here because these aren't some of our special angles. Now, to use your calculator, you have to know how to switch back and forth between degrees and radians, and you have to make sure that your calculators are in the correct mode. So, if you have either of these two calculators, you can see that right here, it tells you that you are in degrees. To change it, you'll hit mode on either of them. You go over, select radians, and then quit, and you'll see right here that it's changed to radians. Now, if you do a complete memory reset on these by holding down your on button, which is down here, and clear, it clears your memory, and it also switches you back to degrees. So you need to be careful about that. But the way you're going to do your calculations is going to be the same on both of these. You just need to make sure that you are in the correct mode. Now, if you have this calculator, then you need to hit mode here, and you'll pick radians or degrees based on here. Okay? So you'll always need to check to make sure that you are in the correct mode. Okay? So let's just find tangent of 32 degrees. So here, I'm making sure that I am in degree mode. I'll hit tangent, and then 32, close parentheses, and I get that value. I'm supposed to round to two decimal places. So this is approximately 0.62 is your value. Now, what happens if you accidentally do that in radians? You can see that you get a very different value. So you cannot trust your calculator unless you are really positive that you are in the correct mode. Okay? Cosecant of 72 degrees. Okay? Remember, we do not have a cosecant button, so we have to take the reciprocal of this. This is 1 over cosecant goes with sine of 72 degrees. This one is in degree mode. So there are two ways I could calculate this. I could find sine of 72 degrees and then ask it to find the reciprocal by doing the 1 over blank button or x to the negative 1 button, depending on what your calculator has. And it will give me my answer. That is approximately 1.05. The other way you could have done it is use fraction mode and do 1 over sine of 72 degrees, and you should get the same answer. But you have to remember to do the reciprocal yourself. These buttons mean something different. Okay? So let's find tangent of 2 pi over 9. This is not in degrees, this is in radians, so I need to make sure that my answer, my calculator is in radian mode. And here I have tangent of 2, make sure you use your pi button, 2 pi over 9, close, and this is approximately 0.84. Okay, now let's talk about an application of this. If the depth of water, which is d feet, in a channel t hours after midnight, is given by this function, d is equal to 3 times cosine of pi over 6t plus 10. We're asked to find the channel depth at noon, and then find the channel depth again at 6 p.m. Now, t is in hours after midnight. Noon is 12 hours after midnight. So for this one, our t value is 12. At 6 p.m., that is 18 hours after midnight. So for this calculation, our t is going to be 18. So at noon, I'm going to plug in 12 for t, and my depth is 3 times cosine of pi over 6 times t. Pi over 6 times 12 would be 2 pi plus 10. What is cosine of 2 pi? Well, 2 pi is 0. Cosine is our x-coordinate, so that is 1. So I have here 3 times 1 plus 10, which is 13. So at noon, that channel is 13 feet deep. Let's do the same thing when our time is 18. So that's d equals 3 times cosine of, if I multiply pi over 6 by 18, that gives me 3 pi plus 10. Well, 3 pi, 2 pi, and then another pi, that's coterminal with pi. So what I have here is the same as 3 times cosine of pi plus 10. What is cosine at pi? -1. So my d is equal to 3 times -1 plus 10. So that is 7 feet. So at 6 p.m., the channel is 7 feet deep. This would be high tide. This is low tide. Okay, now one more type of problem here. If my x value is the square root of 3 over 2, and I know that my y value is positive, we're asked to find a cosine and sine. So let's just do our calculations. If this point is on my unit circle, then I know my unit circle has to satisfy x squared plus y squared is equal to 1. We have an x value that works. So square root of 3 over 2 squared plus y squared equals 1. This is 3/4 plus y squared equal to 1. So y squared is equal to, that ends up being 1/4. And then algebraically, you take the square root of both sides and you get plus or minus. But we know that our y value is positive. So if I just take the square root of 1/4, I get 1/2. So that means the point that I'm interested in, the point on the unit circle that I'm interested in, is the square root of 3 over 2 and 1/2. Now this is enough to find sine and cosine. Sine of this point, this arc length, would be 1/2. It's my y coordinate. And then cosine of t is my x coordinate. So you've done all of these steps before, it's just they mixed them all together.